A. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
Okay, so you might have guessed, hold on, guess that we're looking at vectors. So this unit, we were talking about vectors. A vector has direction and magnitude. So we're going to be talking about these directed line segments. In other words, we have a starting point, and then it's going to a different direction. So we have a direction and a magnitude. In other words, the length. So magnitude is another name for the length. So magnitude, length, that means the same thing. And the notation we use is this absolute value because, well, absolute value is the distance from the origin. We can think of it as a distance or length. Now, everything we're going to be doing in this unit, you're going to want to make sure your calculator is in degrees. All right. Now, the next thing we're going to talk about is equality. Two vectors are equivalent if they have the same magnitude and the same direction. So the magnitude is found by using the distance formula or Pythagorean theorem. And the direction we'll find by using the slope. So we're going to show that U and V are actually equivalent even though they're not in the same position. What we're going to look at first is the magnitude. So that would be the magnitude of U would be the distance between 0, 0 and 3, 2. So the formula for distance, we'd take the difference in our x's, so 3 minus 0 squared, and then the difference in our y's, 2 minus 0 squared. So that'd be 3 squared plus 2 squared. That'd be square root of 13. Now let's look at v. So v, we have 4 and 1, so 4 minus 1 squared, and then 4 minus 2 squared. That's 3 squared and 2 squared. Those match. Now the next thing we're going to look at is our slope, but we can also think of that, a better way to think of it is the angle. So we know that this was 2 high and 3 long, and this is 2 high and 3 long. So if I looked at the tangent of that angle, that's opposite over hypotenuse, that's 2/3. So in both of those triangles, our slope is 2/3, our tangent is 2/3, and I could actually find that angle, that direction for both of them. And we do that by doing the arctan of 2/3. And it'd be the same angle because they both have the same slope, the same direction. So I would make sure I'm in degrees. And then we're going to do arctan, so shift tan of 2/3, and it gives me 33.69. So the angle for both of them is 33.69 degrees. I would show that the angle for both of them is the same. So that's how we would prove that they are the same, that their magnitudes match, and their directions match. In other words, their angles match. Now there's something called component form of a vector. And the component form is the difference in the x's, comma, the difference in the y's. So if the first is the difference in the x's, and this is the difference in the y's, then that can help us find our magnitude. This is the difference in the x's squared plus the difference in the y's squared. So the first thing we're going to do is find the component form and magnitude of this point. So it's starting at P. So that's our x1 and y1. So 4, negative 7. x1, y1. And we end at Q. That's where the arrow points to. And that's negative 1, 5. That would be x2, y2. So to put it in component form, we're going to take the difference in our x's, so x2 minus x1, then y2 minus y1. So that would give me negative 5, comma 12. What that's telling me is that to get from point P to Q, I'm going to go left 5 and up 12. Now that makes it very easy to find our magnitude from vector form because the difference in our x's is negative 5 and the difference in our y's is 12. So that'd be 25 plus 144 square root of 169. That's 13. Now let's look at some operations with vectors. Let's say we have two vectors in vector form, in component form, and it asks us to find 2 times vector v. Well, guess what? That just means to take 2 times vector v. Now notice when we write these component forms, we're using these pointed parentheses, so it's arrows and not parentheses. So this new one would be negative 4, comma 10. It'd be twice as long, or twice the width and twice the height. W minus v would mean to take vector w minus vector v, and we would subtract our x components. So 3 minus a negative 2 would give me 5, and then 4 minus 5 would be negative 1. V plus 2 times w. So 2 times w would be this. V was negative 2, comma 5. So 2 times w would be 6, 8. If I add those together, I get 4, 13. Now, a unit vector is a vector with a magnitude of 1. We can convert any vector into a unit vector by using this formula. We take the vector divided by its magnitude. So let's use vector v, negative 2, 5. The first thing I'm going to do is find its magnitude. So I would be doing negative 2 squared plus 5 squared. That would be 425. That'd be the square root of 29. To find the unit vector for vector v, we are going to take vector v divided by its magnitude. So vector v is negative 2, comma 5, and I'm just going to divide each of those components by the square root of 29. Now, unit vectors can also be written as linear combinations. So we have an initial point here. So the initial is 2, negative 5. That's our x1, y1. And our terminal, where we're stopping, is negative 1, 3. That would be our x2, y2. Let's start by finding our component form again. Our component form, we'd find the difference in our x's. Whoops, that should be the difference. Oh, and then 3 minus a negative 5. So that would give me negative 3, comma 8. In linear form, linear combination, all we're going to do is write this using the unit vectors I and j. I is going to be our x unit vector, and j is going to be our y unit vector. So this would be written as negative 3i plus 8j. Now we can perform operations with linear combinations as well. And it's super easy. If it says to take 2 times u, that literally means to take 2 times u minus 3 times v. We're just substituting in and distributing and then combine like terms. Now this is equivalent to the vector negative 12, 19. Finding direction angles. We already talked about this a little bit. Finding the direction angle for u, which is 3i plus 3j. So 3 for the x, 3 for the y. If I make that into a right triangle, I got 3 and 3. So the tangent of that angle would be 3 over 3. We would do arctan of 1. If you could do that in your calculator, you're going to get 45 degrees. Now, if I have 3, negative 4. Okay, so let's think about where that would be. 1, 2, 3, 1, 2, 3, 4 down. We're looking at this angle right here. So our y is negative 4, our x is 3, tangent is going to be the y value over the x. So we would do arctan of negative 4 thirds. And let me show you what we end up getting on that one, and let's talk about it. So when I do arctan of negative 4 thirds, I get negative 53.13, which is right if I was going backwards. But what if I wanted to know the positive angle? Well, I would just add 360. So 360 plus a negative 53.13, that would give me the positive coterminal angle that lands in the same spot. All right, find the component form of the vector that represents the velocity of an airplane descending at a speed of 100 miles per hour at an angle of 30 degrees below the horizon. So it's saying that below the horizon is 30 degrees. So this whole angle theta would be 180 plus 30. Our theta is going to be 210. Now our magnitude, notice it's 100, so the magnitude is 100. So this component form we can find by taking our magnitude times the cosine of that angle, I, plus the magnitude times sine of that angle, and put a j. So if I put 100 cosine of 210, that's negative 50 square root of 3, I, and then 100 sine 210 is negative 50, j. Now that's written in linear form. You could also write it as negative 50 square root of 3 and negative 50. Both of those are equivalent. They mean the same thing.